Okay, so let's talk about inverse of functions today. So what an inverse is, think of an example. Normally, we would say, what is maybe your income, given that you work X hours, okay? Well, the inverse is saying how many hours do you need to work to get X dollars. So it's just, again, just as it sounds, it's the inverse. So we're switching what we're given and what we're looking for. So that's kind of what we're talking about for inverse. When we're talking about an inverse of a graph, though, we're looking at just a little bit different, and there's a set of steps that we're going to go through. Okay, so I'm going to give you the set of steps, and then we'll just start doing it. Now, remember, the variables that I'm using is just generic, but your equations might have something a little bit different. So the first one is we always need to change your f of x to y, okay? And whatever, again, variable that might be. Then our next one, we are going to switch x and y. So we're just going to switch the letters. And then 3, we solve for y. And then 4, we change y to what we call f inverse of x. So let's just go through and give you an example of what I mean by that. So number 1, in this case, it's h of x, so we're still going to change it to y equals negative 4/7 n plus 16/7. Now the next step says to switch the x and the y. Well, it's not x and y. In this case, it's n and y. Or if you want to change and put an x for the n, you can do that. So we're going to switch. N equals a negative 4/7 y plus 16/7. And then the next step says to solve for the y now. So now we're going to take this and we're going to solve for the y. So the first thing that I would do would be to subtract the 16/7 over. And then I'm going to multiply by the reciprocal. And this is where I told you I don't know that I gave you guys enough room, so you might want to do this on your own paper. So when I now distribute that, I have a negative 7/4 n plus, and my 7s are going to cancel, and 4 goes into 16 4 times, and that equals y. So now I'm going to, again, change the y for f inverse of x. Now mine, again, since it's not f, it's h. So I would say h inverse of n equals a negative 7/4 n plus 4. And that would be my inverse function. Okay? Now, the next thing that we're going to do is graph. And in this case, this is your n, and this is your h of n, okay? And like I said, you're always welcome to switch those to x and y's if you're more comfortable with that. And so we're going to first graph our original equation. So that would be 16/7, which would be 2 and 2/7. So I'm just going to estimate where that's at. And then I have a slope of a negative 4/7. So down 4, 1, 2, 3, 4, and 7. Well, they didn't even give me room to put it on there. Okay, so it's going to look something like that. They did not make our line long enough. Okay, and then I'm going to graph also the inverse of it. So that would be at 4 with a slope of a negative 7/4. Okay, now one of the things is how you tell if these are inverses is one line will be the reflection of the other one over the y equals x line. And again, mine's a little bit off just because of the way I'm drawing it here, but you can see that one really is the reflection of the other. Okay, and so those are inverses of each other. Let me run through another one with you. And this one actually has the x and y and f of x in it. So the first step again is to change f of x to y. Next step is to switch the x and the y. Your next step is to solve for y. So I'm going to move the 6 over, divide by the 2. So I'm going to write it in slope-intercept form, and then switch the y for the f inverse of x. Okay, so those are the same steps you're going to go through every time. Now I'm going to graph. So I'm going to graph my original first, and it is at a -6. It has a slope of 2. Okay, let's see if I can kind of hit those points. Okay, then I'm going to do my next one, which is at 3, and it has a slope of 1/2. Okay, and then again, we just draw in the y equals x line, which is right here. And do those look like reflections over the line? And hopefully your answer is yes. So that is how we find the inverse of an equation. We're going to use that all year long with every one of our functions. We use those same steps. Okay. So the next one, now let me mention, if it's not in slope-intercept form, you could put it in slope-intercept form like number 7 if you wanted to go ahead and rewrite that into f of x equals, and you could switch it, -7 force x plus 5, if that helps you. You don't have to, but if you, that would help. Okay, so the next one is state if they are inverses. So one of the ways that you could do it is you could just take your g of x and just find the inverse of it, okay, and then see if it actually is f of x. The other way you can do it is what we call a composite of functions, and that is when we simply take what we call g composite f, and we do f composite g. What that simply means is I'm going to take, it's like a substitution that we're doing right now. I'm going to take f and put it into g, and then I'm going to put g into f as a substitution. And so the first time I'm going to take f, and I'm just going to put it right there into g. So I'm going to put -4 plus 3/4 times the -4 plus 4/3 x. Now this is doing it this way. And then when I simplify, if they are in fact inverses of each other, this answer will be x all the time. So let's see what we get. So when I simplify here, I get a -3 plus, and then when I multiply, I get an x. And it looks like in this case, oops, that I am going to get a -7 plus x. And again, this has to be equal to x in order for it to be a function, so the answer is no. Now, if this worked and you got x, you would also need to do it the other way also, the f into the, or the g into the f. So let me try another one here for you. So I'm going to do number 12. Okay, so the first thing that I'm going to do, and when I write it this way, it is f into g. So I'm going to take the f and put it into the g. So that would be 3 times 1/3 n plus 1. When I simplify that, I'm going to get n plus 3. minus 3. I forgot the rest of my equation. Minus 3. Okay, so I'm taking this and I'm putting it right there. And this is equal to n. So far it looks like they are inverses. Now I said it equals x. In this case, our x's are n. So now I'm going to do it the other way. And I'm going to put the g into the f. So I'm going to have 1/3 times 3n minus 3 plus 1. That gives me n minus 1, and then the plus 1 outside, which gives me n, which it checks. Therefore, yes, these two are inverses of each other. Okay? So it does have to check both ways in order for it to be true, but as soon as one of them doesn't work, you know the whole thing doesn't work. Okay, that is how to find inverses of a function. So hopefully that makes sense, and good luck.